Hi there, and welcome to this video on applications of systems, where we're going to see where we can see systems used in real-world scenarios. As always, like and subscribe for more math help, drop a comment or question below, and check out the other videos and playlists on the channel and see what else we can help you with. As mentioned in a previous video, so we started this unit or section on systems of equations, and I had a lesson that I just kicked off with. It was like Introduction to Systems of Equations. And I kind of addressed this in that video. So if you saw that video, this might be a little bit of a repeat for you. There are loads of applications for systems of equations outside of math class. So they are not something that you study in a math class and then might not ever see again, or only see in some narrow situations. Like, we really do have some good applications. Unfortunately, some of the best examples are very contextually complicated. And what I mean by that is they require you to know physics or finance or some other outside knowledge. So the places where you might see systems of equations come into play, you actually need a lot more than just the math background. So you'll be sitting in a physics class or maybe sitting in a business class, and all of a sudden this situation will come up and it'll be a system. And at that point, you need to draw on your math knowledge. You need to kick back to Algebra 1, Algebra 2, your math skills to be able to solve the problem. But it makes it really hard to practice in math class because a lot of those examples are contextually complicated. So typical problems in a math class usually involve unrealistic situations that just allow you to practice your interpretive skills. So the goal for a lot of the word problems are more than just like, here's a real life situation. They're more about being able to look at a situation and recognize that it is a systems problem, not that the situation itself is realistic, because then when you are in these other situations, you will have that skill set to say, oh, wait a minute, this is a system, and I know how to solve systems. So unfortunately, that's just what a lot of the word problems are like, and I've always found them kind of hokey. Now, in this lesson, we'll look at some problems that I hope aren't too cheesy and give you a sense of how and when we engage systems in the real world. So what do these problems sound like? What do they look like? How do you go about setting them up? And in the future, when you encounter them, you'll have that skill set in place. Now, if you're coming into this video cold and you have not actually gone over the strategies for solving systems, I am going to approach this with the assumption that you are comfortable graphing, using substitution, and using adding as methods for solving systems of equations. So if you don't know that, please take a moment and hop back on the channel and watch those videos, lessons, maybe work a couple of those example problems before you dive into the applications. So here's our first example. You are working in a retail shoe store. Over the course of the day, you sold 36 pairs of shoes in 2 styles. Now, in the 2 styles, that's probably the unrealistic thing, because if you are working in a shoe store, you're going to sell more than 2 different styles. However, because we are practicing on systems and we were only working with what we call 2x2 systems, where we have a variable for X and Y, we need to keep it to 2 styles. Now, if you're wondering, well, could you do a problem like this with more variables, with like, say, 7 or 10? Yes, you could. It would require a lot of equations. So you'd have to have a lot of different relationships that you knew about. It would also be awful. So for now, we're just going to keep it to 2 styles. Now, in the course of the day, you sold 36 pairs of shoes, 2 different styles, and you took in $1,500. Now, the computer was supposed to track how many of each style you sold, so you can keep track of your inventory. But at the end of the day, it malfunctioned, and now you need to figure it out by hand. And we live in this technological age. You are watching this video on YouTube. We know stuff malfunctions. So the idea that something was supposed to have been tracked and then it did not get tracked, is not this wildly unrealistic thing. So you sold 36 pair, you took in $1,500. You need a little bit more information though before you can figure it out. Now, style X sold for $50 and style Y sold for $35. And that's the other piece of information you need to have. How many of each style shoe was sold that day? So to do this, and a lot of times we don't write this out, but I'm going to define this is like X is the number of pairs of style X and Y is the number of pairs of style Y. And just because my students ask me this, that is a really sloppy cursive like word of, okay? Just so you know there. It's like like of. And when I write it really fast, it starts to end up looking like a warped Q, just so you know. So nobody's gonna be like, what is she writing there? Okay, now the two equations that we're going to write, we're going to write an equation for the number of pairs, and then we're going to write another equation for, not number, for the amount of money. So those are like the two, I don't know, branches of information that we know. We know stuff about the number of pairs and we know stuff about how much money we took in. So here's what I know. In terms of the number of pairs, I know that we sold 36 altogether. So if X is the number of pairs of one style and Y is the number of pairs of the other style, then X plus Y would have to equal 36. Now, the other piece of information has to do with the money. Now, we are told that style X sold for $50. So if I take the number of pairs of style X and I multiply that by 50, that gives me the amount of money that we took in for style X. So $50 times however many pairs of shoes we sold. And then we do the same thing with style Y, which sold for $35. Okay, and that's the total amount of money that we took in for style Y. It would be awesome if I wrote a Y. There we go. And we know that that total amount of money was $1,500. And there are the two equations. So one for the number of pairs of shoes and the other for the amount of money that you're dealing with. Now, once you get here, you are free to solve this any way you want. So we could hop on over to Desmos or use a graphing calculator. We could solve it by graphing. This one, you could solve it fairly easily, both by adding and using substitution. So I'm going to go with adding. That's just what I'm going to do. I'm going to go with adding, and I am going to eliminate the y's. Okay. And again, I am making that decision there. So I've got 35y right here. If I could make this a negative 35y, then I would be able to have them drop out. And I can do that by multiplying that top equation by a negative 35. So that brings me to this. We've got negative 35x minus 35y equals negative, and then I've got to do 35 times 36, and that is 1,260. Bottom equation, we're going to leave alone. Okay. And negative 35x plus 50x is 15x. My y's are going to drop out. Negative 35y plus 35y is 0. And negative 1,260 plus 1,500 is 240. And we'll divide both sides by 15. And we get x is equal to 16. So it looks like style X, we sold 16 of those. And then probably the easiest way to figure out what y is to use like x plus y is equal to 36. We now know that we sold 16 of style X. So we'll subtract 16 from both sides, and we sold 20 of style Y. Now, that is not the only way to do that, okay? Now, I really think those are the two equations you've got to come up with. But again, once you have those two equations, you could elect to eliminate x and multiply by -50 instead of -35. You could solve that top equation for either x or y and substitute it into the other equation. So you really have a lot of options for how you want to go about solving it. Whatever you do, always follow your teacher's directions and make sure that your work is clear, okay, that it follows in some kind of organized way, and nobody's going to be staring at your work saying what is happening here. All right. Next one, you are making 10 liters of a fruit juice blend. You mix apple juice costing $2 per liter, and what are you mixing? With grape juice costing $4 per liter, and your budget for the entire blend is $30. How much of each type of juice should you add? So again, we've got like a cost piece of this going on here. So we've got, I'm going to use A for apple juice and G for grape juice, and we'll make A is the amount of apple juice and G is the amount of grape juice. And all together, we are trying to make 10 liters. Okay, so we need 10 liters of this juice for some kind of party. The second equation is going to have to deal with the cost. Now, the budget, like this again, is where we run into this piece of like, this is not realistic because nobody actually cares if you come in under budget usually, unless you're under some kind of contract where you got to spend all your money or you lose the money. So let's assume it's that. Okay, so you actually need to spend all $30, and you want to get the best blend possible of that. So the apple juice is $2 per liter. So if you multiply the number of liters of apple juice by 2, that'll give you how much you're spending on the apple juice. And the grape juice is $4 per liter. So if we do 4 times G, okay, that gives me the amount of money I'm spending on the grape juice, and my budget is 30. Now, there's several different ways you could do this. So the first thing that's jumping out at me here is that 2a plus 4g equals 30. I could divide both sides by 2 or multiply both sides by 1/2, and I could shrink those numbers down. So I wasn't dealing with as big of numbers. The last one I opted to solve using adding. So this one I'm going to solve using substitution. So I'm going to take that top equation and I am going to solve that top equation for A. Okay, now could I solve it for G? Absolutely. Okay, this is where you and your neighbor should not be having identical work. And now I'm going to take that and I'm going to plug that into the other equation in place of the A. So we're going to have 2, and then instead of A, we're going to have 10 minus G plus 4G equals 30. And now I have an equation with just G's in it. So 20 minus 2G plus 4G equals 30. Negative 2G plus 4G is 2G. We're going to go ahead and subtract 20 from both sides. Okay, there was just a really loud noise in my apartment, which I really hope is my cat. That freaked me out for a second. Okay, so we're going to have 2G is equal to 10. And kind of ran out of space there. Divide both sides by 2, and I get G is equal to 5. So we need 5 liters of grape juice. And then remember that A is equal to 10 minus G, and now we know that G is 5. So 10 minus 5 is 5, and we need 5 liters of apple juice. Ta-da! All right, one more example. A blacksmith is creating 20 kilograms of a bronze alloy. He uses one alloy that is 40% copper and another that is 70% copper. The final mixture must be 50% copper And you were being asked how many kilograms of each alloy should be used. So let's take a look at this. So we've got, we're just going to call it like alloy X and alloy Y. And we know that the two alloys added together need to come to 20 kilograms. Okay, so we have one equation that has to do with the amount. And then the other equation is going to be to do with like what percent. Okay. So here's what we need to know or need to have. So the first alloy, we'll call that 40%. Okay, 40% copper alloy. Now, quick little thing we need to remember here. 40% literally means, okay, the word percent means out of 100. So this would be 40 out of 100 or 0.4. Okay, so that's a little sidebar on percents. So what we're going to do is take the amount of that first alloy and multiply that by 0.4. And what that's going to do is find 40%. That gives us like the amount in that particular chunk. So it's 40%. And then we're going to do the same thing with this one, only this is 70%. And then the overall percentage needs to be 50%, and it would be 50% of the total, which was 20. So essentially we have one equation that gives us the amount and the other equation that is setting up the percent. So I have a certain amount of the 40% and a certain amount of the 70%. And when we merge those together, we need to come up with a 50% alloy. Now from here, there's, again, a lot of ways you can solve it from here. So you can go and graph it. You can use substitution, adding. What I did first was I multiplied everything in this bottom equation. Did I turn on my highlighter? I don't know if I turned my highlighter on. We want the highlighter. There we go. I took everything in the bottom equation and multiplied it by 10. And the reason I did that is because I don't want to deal with those decimals. I can deal with decimals. I just don't want to. So I'm going to multiply everything by 10. So I'm going to have x plus y equals 20. By multiplying by 10, the 0.4 becomes a 4. The 0.7 becomes a 7, and the 0.5 becomes a 5, and 5 times 20 is 100. And I just like that equation better, okay? You are welcome to keep all the decimals in there. There'd be nothing wrong with that. Now, for this one, I'm going to do adding again, and we'll try to eliminate the x. So I'm going to multiply that by -4. So that my x's will eliminate. And while I'm writing this, what do we have here? -80. I will remind you that if I am absolutely losing you on that step and you're like, where did you come up with the -4? Why? You need to go back and do the lesson on how to solve systems of equations by adding. Okay, don't try to hang on for dear life. Okay, like we need to go back and get that piece where the only thing we're focusing on is how do we decide what to multiply by. -4x plus 4x is 0. -4y plus 7y is 3y. And -80 plus 100 is 20. Divide both sides by 3. And this comes out to like 6.666666666. Okay. Like forever. So I'm going to say that's 6 2/3 kilograms. So love that. Ooh, love it so much, except I don't. But you know, the last part of this isn't too bad. So x plus y is equal to 20. I now know that y is 6 2/3. So we're going to go ahead and subtract 6 2/3 from both sides. And that is going to give me, what does that give me? 13 1/3. Okay, and so the two different alloys, we would need 6 2/3 and 13 1/3. Now, if I kind of lost you on the fractions there, you can always use a calculator. At least in most cases, you can use a calculator. I don't want to get too in the weeds of like the fraction arithmetic. If you followed the algebra part, you're fine, and then you hope you don't see like awful problems on your own. Now, I want you to try some, and because there's only 2 practice problems, I didn't want to do an entire separate video for the practice work on this one. So I rolled it into the lesson. Pause the video, try these ones out on your own, and then unpause the video and we will go over them together. Okay, so a coffee shop wants to make 100 pounds of a coffee blend that sells for $6 per pound. Not crazy. They want to sell their own personal blend, and they have a price point set. Now they're going to mix some high quality beans that are $8 per pound with some lower quality beans that are $4 per pound. And the question is, how many pounds of each type of bean should they use? So I'm gonna call them the high quality beans and the low quality beans. And if we add the high quality and the low quality together, we want to come up with 100 pounds. There we go. Now, if we have the high quality and the low quality, the high quality was $8 per pound. So $8 times the high quality plus $4 times the low quality. That's like how much of each type is going in there. And then we want the final amount to sell for $6 for the 100 pounds. So we want it to come to $600. Okay, that's the amount of money that we want to go put in there. And how do we want to solve this? I don't know. I kind of want to make that other equation smaller, but let's not. We'll keep it pretty cut and dried. We did the last one by adding, so let's do substitution on this one. The high quality, we'll subtract the low quality from both sides, is equal to $100 minus the low quality. And then we'll come into the other equation and substitute that in. So 100 minus L plus 4L is equal to 600. So this is 800 minus 8L plus 4L equals 600. Combining my like terms there, negative 8L plus 4L is negative 4L. And subtracting 800 from both sides, we get negative 4L is equal to negative 200. We'll go and divide both sides by negative 4. And negative 4 divided by negative 4 is 1. And a negative divided by a negative over here is 50. And so we want 50 pounds of the low quality beans. And remember that the high quality beans plus the low quality beans needs to total 100. And so we can just subtract 50 and we get the high quality beans. 100 minus 50 is 50. And that is also 50 pounds. Now you might look at that and say, well, I could have kind of figured that out because we wanted it to sell for $6 and 6 is halfway between the 4 and the 8. Therefore, it would split right down the middle and we would need half and half, which would make it 50 and 50. If you kind of went there with that, that your intuition is completely correct. Okay, intuition is completely correct. Yes, you could do that. You see that on your SAT. If you're doing like a math competition, like go for it. If you are asked to set up the system of equations and solve it and justify it, then you do need to go through the process. So, and then it would be very, very easy for a teacher to change that. All they would need to do is change like the price point of the amount that they wanted to sell it for, and then that will change the ratio. Now, could you probably still figure it out another way? Yeah, you probably could, but this is going to be pretty reliable, okay? Because you might end up in a guess and check kind of situation. All right, last one. A chemist needs 12 liters of a 30% acid solution, and she has 10% acid and 40% acid on hand. So what she needs and what she has don't quite match up. I like this kind of problem because this is a realistic kind of thing where what you need and what you have don't quite match up, and you want to be a problem solver. So she needs 30%. She's got 40 and 10. How many liters should she mix to get the desired amount? So in other words, she needs to take that 40% acid solution and she needs to water it down with the 10% acid solution until she gets a 30% acid solution. But she can't just like dump it in and keep checking because she needs 12 liters of it. She doesn't want more or less than the 12 liters. So while you might be able to do something like this with a little bit of guessy and checky, you don't want to, if this is your boss, don't, okay? You got to be responsible. So we're going to call the X, we'll call this the 10% solution, and the Y will make the 40% solution. And if you add them together, you need 12 liters. So once again, you have an equation that is a particular amount. Now, the other equation will have to do with the percentage of the acid. So again, 10% means 10, literally per 100, think about pennies in the dollar, okay? That means 10 out of 100 or 0.1. So if we have the 10% solution plus the 40% solution, the final solution needs to be 30% over that 12 liters. And I'm going to do what I did in the last one, which is I'm taking everything in that bottom equation and I am multiplying it by 10 because I don't want to deal with those decimals. So 10 times 0.1 is just 1. 10 times 0.4 is 4. 10 times 0.3 is 3. And 3 times 12 is 36. So my two equations now are x plus y equals 12, and 1x is also just an x plus 4y equals 36. And what I'm going to do here, because I feel like doing stuff differently, because why not? I'm going to use the subtraction method that we looked at in the adding one. I showed you how this worked, okay? So essentially, I'm going to take that bottom equation and I'm going to subtract it because x minus x is 0. Y minus 4y is negative 3y, and 12 minus 36 is negative 24. Divide both sides by negative 3, and I get y is equal to 8. So she needs 8 liters of y. So 8 liters of, what was y? Y was the 40% solution. And then we know that x plus y is equal to 12. So x plus 8 is equal to 12. We're going to subtract 8 and we get x is equal to 4. So she needs 4 liters of the 10% solution. And before you leave the problem, make sure that it makes sense. So if you think about like the number line, okay, here's my number line. And we've got 10, 20, 30, 40, okay? This is what she's got. She's got 40 and she's got 10. And this is where she wants to be. She needs the 30%. Well, notice that 30 is closer to 40 than it is to 10, okay? Therefore, she doesn't want to split it like right down the middle. If you split the 40 and the 10 right down the middle, like you're not going to land, you're going to land at what, 25? So she needs more of the 40% solution than she does of the 10% solution. And so your answer does make sense. And you might even say, well, oh, look, I see like a similar ratio there. Like that is a 1-to-2 ratio. Okay, and then you look over here and you're like, oh, this is like a 1-to-2 ratio. Isn't that interesting? I think that's interesting. I'll let you ponder that. Okay, So that's it. Don't forget to like this video if you found it helpful. Subscribe for more math content. Drop a comment question below and check out some other videos that we have on the channel. I hope that this really helps you with some of the applications for systems problems, and you will find that like most system problems will have a feel like this, where there's money or time or amount, that kind of thing. You have two things, you write your two equations, and then have at it for how you want to solve them. All in less than 30 minutes. So again, give me a like if you found this helpful, and I will see you in the next one.